The night sky has always whispered secrets to those who dare to listen, its vast canvas of stars, a silent promise of mysteries waiting to be unraveled. In 2017, that whisper became a shout, a cosmic call that shook the foundations of our understanding. A strange, fleeting visitor from beyond our solar system streaked through the heavens, leaving scientists, dreamers, and stargazers alike grasping for answers. Its name was Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. And its arrival was nothing short of a revelation. This wasn't just another rock tumbling through space, it was the first confirmed interstellar object to grace our solar system, a wanderer from the depths of the galaxy, carrying with it the weight of a million questions. Was it a comet, an asteroid, or something far stranger? A relic of a long-dead world, or perhaps a crafted artifact from an alien civilization? The possibilities ignite the imagination, stirring a potent mix of awe, curiosity, and a touch of existential unease. Join me on a journey to chase this cosmic enigma, to peel back the layers of Oumuamua's mystery, and to explore the audacious dream of catching up to it before it vanishes forever into the void. On October 19th, 2017, the Pan-STARRS 1 telescope in Hawaii, perched atop the ancient volcanic slopes of Haleakala, caught a fleeting glimpse of something extraordinary. Funded by NASA's Near-Earth Object Observations Program, this telescope was designed to scan the skies for asteroids and comets that might threaten our world. But that night, it found something far more profound. At 33 million kilometers away, a faint speck moved with a velocity that defied everything we thought we knew about objects in our solar system. Clocking in at over 314,000 kilometers per hour, 4 times faster than the average solar system traveler, this object was a speed demon, hurtling through space with a purpose all its own. At first, the astronomers thought it might be an asteroid, a rocky fragment like those that orbit our sun. But there was a twist. It was accelerating, ever so slightly, in a way that echoed the behavior of comets, which release gas and dust as they near the sun. Yet, Oumuamua showed no such telltale signs, no shimmering coma, no trailing tail of debris. It was a paradox, neither fully comet nor asteroid, a riddle wrapped in the starlight of a distant origin. The discovery sent ripples through the scientific community, a spark that ignited a global frenzy of observation and debate. This wasn't just another celestial body. It was the first confirmed interstellar object, a visitor from another star system that had wandered into our cosmic backyard. Astronomers estimate that such objects pass through our solar system roughly once a year, but they're usually too small, too faint to be noticed. Oumuamua was different. It was big enough, bold enough to be seen, and its presence carried the weight of cosmic history. Named with a nod to its Hawaiian discovery, Oumuamua became a symbol of the unknown, a messenger bearing secrets from a place we could only imagine. Observatories around the world turned their eyes to the sky, desperate to capture every detail before it slipped away. The European Southern Observatory's Very Large Telescope in Chile joined the hunt, its massive mirrors drinking in the faint light of this distant traveler. What they found only deepened the mystery. Oumuamua wasn't just fast, it was strange. Its brightness fluctuated wildly, shifting by a factor of 10 every 7 hours as it spun through space. This wasn't the behavior of a typical asteroid or comet, which tend to be roughly spherical, like cosmic boulders. Instead, the data suggested something extraordinary. Oumuamua was elongated, a cosmic cigar stretching up to 1,000 meters long, but only 35 meters wide. Imagine 10 football fields laid end to end, yet barely wider than 2 bowling lanes. This shape was unlike anything we'd seen in our solar system, a form so alien it seemed to defy the laws of celestial mechanics. Its surface, too, told a story. Bathed in a reddish hue, It resembled the weathered objects of our outer solar system, its color likely forged by millions of years of cosmic ray bombardment. This wasn't a pristine chunk of rock. It was a survivor, a fragment that had endured an unimaginable journey across the Milky Way, perhaps for hundreds of millions of years before crossing paths with us. As Oumuamua sped through our solar system, passing the orbits of Mars, Jupiter, and Saturn, it left astronomers scrambling to keep up. Its trajectory was traced back toward the direction of Vega, a brilliant star in the constellation Lyra, though pinpointing its exact origin was impossible. The stars have shifted over the eons, and Oumuamua's journey may have begun when the constellations we know were unrecognizable. It was headed now toward Pegasus, a fleeting guess that would soon vanish from our view. But its brief visit had already sparked a firestorm of questions. What was this thing? A comet, an asteroid, or something else entirely? The scientific community was divided, with some arguing it was a comet propelled by outgassing as it neared the sun, while others insisted it was an asteroid, a solid relic of a distant world. Yet neither explanation fully fit. Comets leave trails of gas and dust, but Oumuamua was stubbornly silent, showing no such signs. Its acceleration, too, was puzzling. Comets speed up as they approach the sun, not as they recede. Yet, Oumuamua seemed to defy this rule. The mystery deepened as scientists pored over the data, their telescopes straining to capture every last photon from this fading visitor. Some began to whisper a bolder hypothesis, one that sent shivers down the spine. What if Oumuamua wasn't a natural object at all? What if it was a relic, a piece of technology from an advanced civilization, drifting through the cosmos like a ghost ship? The idea was intoxicating, a possibility that stretched the boundaries of what we believe is possible. Harvard astronomer Abraham Loeb fanned the flames, suggesting that Oumuamua's strange acceleration and elongated shape could point to it being a light sail, a spacecraft propelled by the pressure of starlight. Such a craft would need to be impossibly thin, with a mass-to-area ratio that defied conventional observations. Yet the idea lingered, a tantalizing what-if that refused to be dismissed. The thought of an alien artifact passing through our solar system was both thrilling and terrifying, a reminder of how small we are in the grand tapestry of the universe. As Oumuamua slipped further away, its secrets grew harder to grasp. By mid-December 2017, just 2 months after its discovery, it had become too faint for even the most powerful telescopes to track. Yet the questions it raised burned brighter than ever. Was it a shard of a shattered planet, a comet-like planetesimal, or something we couldn't yet comprehend? The scientific community buzzed with theories, each more intriguing than the last. Some, like astrophysicist Roman Rafikov, proposed that Oumuamua was a fragment of a dying star's cataclysm, a piece of a world torn apart by unimaginable forces. Others, like the team at Berkeley's Breakthrough Listen, turned their radio telescopes toward it, searching for signals that might betray an artificial origin. They found none, but the absence of evidence only fueled the mystery. Oumuamua was a puzzle with no clear solution, a cosmic Rorschach test that revealed as much about our hopes and fears as it did about the object itself. The story of Oumuamua is more than a tale of a strange rock in space. It's a mirror held up to our own curiosity, our relentless drive to understand the unknown. It's a reminder that the universe is vast, unpredictable, and full of wonders we've yet to imagine. As we watched this interstellar traveler slip away, we were left with a choice: to let it fade into the darkness or to chase it, to pursue the answers it holds with every tool at our disposal. The hunt for Oumuamua is far from over, and the next chapter of this cosmic saga promises to be even more breathtaking. The stars have always been storytellers, each pinprick of light a chapter in the vast, unwritten book of the cosmos. But when Oumuamua streaked through our solar system in 2017, it didn't just add a new page, It tore the book wide open, leaving us to grapple with questions that felt too big for our minds to hold. Was this strange, cigar-shaped wanderer a mere chunk of rock, a cosmic castaway from a distant star? Or was it something more, a silent envoy from a civilization long gone, or perhaps still watching? The mystery of Oumuamua wasn't just in its shape or speed, but in the way it challenged us to dream bigger, to question deeper. As it slipped further from our grasp, speeding toward the constellation Pegasus, scientists around the world refused to let it go. They turned their telescopes, their minds, and their hearts to the task of unraveling its secrets, and what they found only deepened the enigma. This is the story of the theories that swirled around Oumuamua, the daring ideas that pushed the boundaries of science, and the audacious dream of chasing it across the stars. The first question that gripped astronomers was simple yet maddening. What was Oumuamua? At first glance, it seemed to straddle the line between comet and asteroid, a celestial hybrid that refused to fit neatly into either box. Comets, those icy travelers of the cosmos, are known for their spectacular tails, formed when the sun's heat causes them to release gas and dust in a process called outgassing. This outgassing can act like a natural rocket, giving comets a boost as they swing close to the sun. Oumuamua showed a hint of this behavior. Its slight acceleration suggested some kind of propulsion, but there was a catch. It had no visible coma, no trail of gas or dust, nothing to mark it as a comet. Asteroids, on the other hand, are rocky, solid, and typically don't accelerate in this way. Oumuamua's reddish hue and dense composition pointed toward an asteroid, yet its behavior defied that label. The scientific community split into two camps, each arguing their case with fervor, but neither could fully explain the object's peculiarities. It was as if Oumuamua was taunting us, daring us to look beyond the familiar. As the debate raged, a new voice entered the fray, one that sent a shiver of excitement through the scientific world. In 2018, astrophysicist Roman Rafikov from the University of Cambridge proposed a theory that was as haunting as it was compelling. What if Oumuamua wasn't a comet or an asteroid, but a shard from a dying star? Imagine a distant world, orbiting a star that had reached the end of its life. As the star collapsed into a white dwarf, its immense gravitational pull could have torn apart planets, moons, and asteroids, flinging their fragments into the void. Oumuamua, Rafikov suggested, could be one such fragment, a piece of a shattered world sent hurtling through the galaxy. The idea was both beautiful and terrifying, a cosmic relic carrying the story of a star's death, a reminder of the impermanence of even the grandest celestial bodies. It painted a picture of a universe in constant flux, where worlds are born and destroyed, their remnants scattered like ashes across the stars. But there was another possibility, one that captured the imagination of scientists and dreamers alike. What if Oumuamua wasn't a natural object at all? What if it was a piece of technology, a relic from an advanced civilization that had once thrived among the stars? Harvard astronomer Abraham Loeb didn't shy away from this bold idea. In September 2018, he published a hypothesis that sent shockwaves through the scientific community. Oumuamua could be a light sail, a type of spacecraft propelled by the gentle pressure of starlight. Such a craft would need to be incredibly thin. Loeb estimated a mere 3 millimeters thick, with a structure designed to catch the faint push of photons from distant stars. This could explain Oumuamua's strange acceleration as it passed through our solar system, boosted by the sun's radiation pressure. The idea was staggering. A derelict spacecraft, perhaps abandoned millions of years ago, drifting through the cosmos like a ghost ship, its creators long gone or perhaps still out there, watching from afar. The notion of an alien artifact wasn't just a flight of fancy. It was taken seriously enough to prompt action. In January 2018, a team led by Emilio Enriquez at the University of California, Berkeley, turned the Robert C. Byrd Green Bank telescope toward Oumuamua, searching for radio signals that might betray a technological origin. Their project, part of the Breakthrough Listen initiative, was a bold gamble to detect even the faintest whisper of a transmitter. For 2 weeks, they scanned Oumuamua across its full rotational cycle, listening for narrowband emissions that could indicate an artificial source. The silence was deafening. No signals, no signs of life. Yet the absence of evidence wasn't proof of absence. The possibility lingered, a spark of hope that Oumuamua might be more than a rock, more than a relic. It was a reminder that the universe is vast, and our tools, for all their power, are still limited in their reach. As Oumuamua sped away, the window to study it grew smaller, but the questions it raised grew larger. By 2023, a new breakthrough offered a more grounded explanation, one that didn't require alien technology, but was no less remarkable. In a study published in the journal Nature, Jennifer Bergner from UC Berkeley and Daryl Seligman from Cornell University proposed that Oumuamua was an icy planetesimal, a small comet-like body formed in the protoplanetary disk of a distant star. Their model suggested that Oumuamua had spent millions of years wandering the Milky Way, its icy surface battered by cosmic rays that transformed some of its water ice into molecular hydrogen. When it neared our sun, the heat released this trapped hydrogen, acting like a natural thruster that explained the object's mysterious acceleration. Unlike typical comets, which release heavier gases like carbon monoxide, hydrogen is light and leaves no visible tail, solving the puzzle of Oumuamua's comet-like behavior without a coma. It was an elegant solution, one that didn't need extraterrestrial engineers to make sense of the data. Yet, even this explanation couldn't fully quiet the whispers of wonder. The idea of Oumuamua as a cosmic iceberg forged in the crucible of a distant star system was no less awe-inspiring than the thought of an alien craft. It was a reminder that the universe is a place of endless creation and destruction, where even a chunk of ice can carry the story of a star's birth. And Oumuamua wasn't alone. Just 2 years later, in 2019, amateur astronomer Gennady Borisov discovered another interstellar visitor, 2I/Borisov, a more traditional comet with a visible tail. Suddenly, the cosmos seemed a little less lonely, a little more alive with travelers. Astronomers now believe that interstellar objects pass through our solar system every year, each one a potential key to unlocking the secrets of distant worlds. But Oumuamua, the first, remains the most enigmatic, its brief visit a fleeting chance to glimpse the unknown. The challenge with these cosmic wanderers is their transience. Unlike asteroids or comets that orbit our sun, interstellar objects like Oumuamua follow no fixed path. They sweep through our system and vanish, leaving us with only a fleeting opportunity to study them. By the time we spotted Oumuamua, it was already racing away, 33 million kilometers from Earth and growing fainter by the day. Our telescopes, for all their power, could only do so much. But the dream of understanding Oumuamua didn't end with its departure. Scientists began to imagine a bolder pursuit. What if we could chase it? What if we could send a spacecraft to catch up with this interstellar messenger, to study it up close and uncover the truths it holds? The idea was audacious, almost impossible, but it was a spark that ignited a new chapter in the saga of Oumuamua, one that would push the limits of human ingenuity and ambition. The universe doesn't wait for us. It moves on, indifferent to our curiosity, its secrets slipping through our fingers like grains of stardust. By the time Oumuamua was spotted in 2017, it was already racing away, a cosmic fugitive bound for the constellation Pegasus, carrying answers we might never grasp. Now, over 6 billion kilometers from Earth, farther than Voyager 1 when it captured the haunting pale blue dot in it. Oumuamua is a speck in the vastness, a needle in the infinite haystack of space. Yet its departure hasn't dimmed our hunger to know more. Instead, it's lit a fire, a burning desire to chase this interstellar wanderer and uncover the truths it holds. The dream of catching Oumuamua is a testament to human ambition, a defiance of the impossible that pushes us to the edge of what's possible. This is the story of that chase, the audacious plans to pursue Oumuamua, and the deeper question of whether this cosmic mystery is worth the monumental effort it demands. Catching up to Oumuamua is no small feat. It's moving at 26 kilometers per second, a relentless pace that no conventional rocket could match. By late 2017, just 2 months after its discovery, it had already grown too faint for our most powerful telescopes, slipping beyond the reach of Hubble and the Very Large Telescope. To study it up close would mean launching a spacecraft capable of not just reaching it, but slowing down to gather meaningful data, a task that feels like chasing a bullet with a bicycle. The object's size, roughly 1,000 meters long, makes it a pinpoint target in the vastness of space, tumbling unpredictably as it speeds away. Yet scientists aren't ones to back down from a challenge. The idea of sending a probe to intercept Oumuamua has sparked a wave of innovation, with researchers dreaming up missions that push the boundaries of engineering and imagination. One of the most promising proposals comes from Project Lyra, an initiative by the Initiative for Interstellar Studies. Their plan is a masterclass in cosmic choreography, a daring dance through the solar system to harness the gravitational might of planets and the sun itself. The first trajectory they've outlined is a high-stakes gamble. Launch a probe from Earth, send it hurtling toward Jupiter, and use the planet's gravity to slow it down just enough to fall toward the sun. As it approaches our star, the probe would perform a solar Oberth maneuver, a precise burn of its engines at the point of maximum speed, using the sun's gravity to slingshot it out of the solar system at over 70 kilometers per second. This speed could, in theory, catch Oumuamua by 2048, but the plan comes with daunting challenges. The probe would need a heat shield to survive the sun's blistering proximity, similar to the one used by NASA's Parker Solar Probe. At 72.5 kilograms, this shield would limit the payload, forcing engineers to make tough choices about what instruments to carry. The trajectory itself is a long, looping journey. Earth to Jupiter, to the Sun, and back past Jupiter again, demanding precision that's never been tested in a mission of this scale. Project Lyra's second plan is leaner, more elegant, but no less ambitious. It begins with a launch from Earth, followed by a series of gravitational assists, a swing around Venus, then Earth, a deep space maneuver to tweak the probe's path, another pass by Earth, and finally a slingshot around Jupiter to fling it toward Oumuamua. This route skips the need for a heavy heat shield, allowing for a lighter spacecraft with more room for scientific instruments. It's also shorter, and the slower exit speed would make it easier to decelerate near Oumuamua, giving the probe more time to study its target. Launch windows for these missions are projected between 2030 and 2033, with a potential rendezvous in 2048. Marshall Eubanks, one of the mission designers, believes chasing Oumuamua is not just possible, but inevitable. After all, it's closer than any other star system we might dream of exploring, a tantalizing target that's still within our reach, for now. But the question looms larger than the mission itself. Is it worth it? Space exploration is a costly endeavor, not just in dollars, but in time, effort, and human ingenuity. A mission to Oumuamua would require billions in funding, years of planning, and engineering feats that push the limits of current technology. The solar Oberth maneuver, for instance, is a theoretical concept that's never been tested in a real mission, carrying a low technology readiness level that adds risk to an already daunting task. And what if we succeed? What if we catch Oumuamua, only to find it's a chunk of ice or rock, a cosmic footnote rather than a revelation? The payoff could be immense, a glimpse into the composition of a distant star system, a clue to the formation of planets beyond our own, but the gamble is steep. Some argue we should wait for the next interstellar visitor, banking on new technology to spot them sooner and study them more easily. That hope isn't far-fetched. The Vera C. Rubin Observatory, set to begin operations in 2025, promises to revolutionize our ability to detect interstellar objects. Its legacy survey of space and time will generate 2 million images over a decade, creating a vast database to track comets, asteroids, and perhaps dozens of Oumuamua-like objects each year. Unlike the Pan-STARRS telescope, which spotted Oumuamua only after it had passed the Sun, Rubin could give us 3 months' warning, enough time to prepare a mission. The European Space Agency's Comet Interceptor, launching in 2029, takes a different approach, a probe parked in space, waiting up to 3 years for an interstellar object to pass by. When one does, it will spring into action, performing a close flyby to create a 3D map of its target. It's a bold strategy, the first mission designed for an unknown object, but it's a waiting game with no guarantee of success. If no suitable target appears, the mission could end in disappointment, a costly reminder of the universe's unpredictability. Yet, Oumuamua remains the one that got away, the first to spark our imagination and challenge our assumptions. Waiting for another might mean missing the answers it holds. What if it's more than a rock? What if it's a relic, a message from a civilization that once looked to the stars just as we do? The possibility, however remote, is a siren call we can't ignore. Astrobiologist Karen Meach, who studied Oumuamua in its fleeting visit, believes we're on the cusp of a new era of discovery. With telescopes like Rubin and missions like Comet Interceptor, we're better equipped than ever to catch the next interstellar traveler. But Oumuamua is a reminder of what's at stake. Not just scientific knowledge, but the chance to touch the unknown, to connect with a universe that's far bigger than our own story. The hunt for Oumuamua is a mirror of our own restlessness, our refusal to let mysteries fade into the dark. It's a gamble, a leap into the abyss with no promise of answers, but that's what makes it so human. Whether we chase Oumuamua or wait for the next cosmic visitor, the pursuit itself is a declaration of who we are, a species that looks to the stars and dares to ask, what if? As Oumuamua speeds toward Pegasus, it carries not just its own secrets, but a piece of our curiosity, a challenge to keep reaching, keep dreaming, until we find the answers that await us in the vast, uncharted sea of the cosmos.